are going to talk about the inverse trig functions and their derivatives. Okay? So the first thing we need to remember is what an inverse trig function is. Okay?
That would be cosecant, secant, and cotangent.
Those are reciprocal functions. So, whoa, that's not necessary.
See, guys, closing jobs.
First of all, does this pass the horizontal line test?
Yeah. No, horizontal. Oh.
Okay, so right now, as it is, does this graph have an inverse?
No.
No. So what we need to do is we need to restrict the domain. Okay? If I restrict the domain from negative pi over 2 to positive pi over 2, do we pass the horizontal line test? Yes, we do. And when we take the inverse, remember we talked about this on Tuesday, we take the graph and we reflect it about y equals x. And so when we do that, here is the inverse sine function. We write it two different ways. We can write it as arc sine, or we can write it as inverse sine of x.
Question.
Yes.
Well, if we're like, say, like tangent to cotangent, tangent is y over x, right?
From the unit circle, yes.
So when you think about it, the inverse is something to the negative first, right? So something to the negative first is something flipped over, isn't it?
No, that is called reciprocal. Okay, when we think about inverse functions, okay, here y equals the sine of x. We plug in angles to get numbers out of it, right? Our inputs are angles, our outputs are values between -1 and 1. Here, with an inverse trig function, don't mind me here, we plug in values and get out angles. Right? Our domains and ranges, they switch. So in an inverse trig function, we're plugging in values to get outputs that are angles. Okay? So here our domain is negative pi over 2 to pi over 2. Now our range is negative pi over 2 to pi over 2. Okay. Let's talk about this guy. What graph is this? If we graph the full cosine graph, it's not going to pass the horizontal line test. So I restricted the domain from 0 to pi. Okay? If we do negative pi over 2 to pi over 2, we just get the hill. We don't get the full oscillation. Okay, so that's why it's different, 0 to pi, instead of negative pi over 2 to pi over 2. Okay? Our range, -1 to 1. All right, so then when we find the inverse, okay, we get this graph right here. We write this as arc cosine or inverse cosine. Okay, I'm going to put up all the inverse trig functions up here. You don't have to copy these all down because these are in your book. But, okay, this is, I said you don't have to copy this out, okay? But these are what they are, okay? You focused last year in pre-calculus on these three, right? You evaluated them, whether you remember or not, you did. Okay, so what do these mean? Okay, arc sine of x just means the sine of y equals x. Remember, we're plugging in values and our output will be angles. Okay, there's the domain and range. Arc cosine, arc tangent, Those are the three you worked with last year. We do have arc cotangent, arc secant, and arc cosecant. Okay, they can be written like this, or like cosine with a -1, secant with a -1. They mean the same thing. You'll see them both ways. Most times, though, on the AP test, you're going to see the arc tangent, the arc cosine. So, okay. So what we're worried about today are the derivatives. Okay. So let's talk about the inverse derivative, or the inverse tangent's derivative. Okay. So what I am going to do is I'm going to give you the rule, and then I'm going to show you why it is the rule. I know some of you care and some of you don't, but I do think it's important for me to show you why these rules are what they are. Okay, so I will tell you that our rule is 1 over x squared plus 1.
And that goes for just the inverse tangent, right?
Mm-hmm. Yes. So let's talk about why that is the rule. If y equals the inverse tangent of x, what does that mean? If I rewrite this as tangent, what does this mean? X equals the tangent of y. Okay? Let's take the derivative here. Can we do that?
Yeah.
Yeah, implicitly, right? Mm-hmm. So if we do implicit differentiation, what is the derivative of x? Tangent? Secant squared of y times dy dx. So if we solve for dy dx, we have 1 divided by secant squared y, which is the same thing as cosine squared y. Okay, but we like our rules to be in terms of x, right? We're taking the derivative with respect to x. We want our derivative to be in terms of x. So where do we get that 1 over x squared plus 1? Is a relation of triangles, right? The tangent of, excuse me, this would not be theta. The tangent of y is x. So our opposite over adjacent ratio should be x. Correct? All right. What does that make our hypotenuse?
X squared plus 1. Square root of x squared plus 1.
The square root of x squared plus 1. We do the Pythagorean theorem. Okay? So if we have the cosine of y, what is the cosine of y?
Over that.
Okay, adjacent over hypotenuse, right? So we would have adjacent over hypotenuse squared, which is why our derivative is 1 over x squared plus 1. That is why it is what it is, okay, because of these inverse relationships. Okay. Am I going to ask you to regurgitate this? No. Do you need to know this? Yes. Okay. We can sit here and we can do this for every single inverse derivative. Okay. I don't think you want to do that though. So here they are. I'll give you a little bit of time to write these down. And then I'll show you how to remember which ones are which, okay? As you're writing these down, what do you notice about the ones on the left compared to the ones on the right? Okay, so I've organized them. Okay, can you see? Basically, if you can remember the ones on the left, you can remember the ones on the right because they're just opposite. They're negative. The ones you will see most often would be inverse tangent and inverse sine, followed by inverse cosine. Okay, those would be the three that you would see most often, and that you could expect to see more like on the AP test. Okay. Notice if you know inverse sine, you know inverse cosine. Are we ready for some examples? Okay. Remember, the chain rule is still going to apply. Okay. So if there's something inside of our inverse function, we still have to do the chain rule when we take the derivative. Okay, but we just need to follow these rules. Okay. So let's start with this one. The arctangent of 2x. So when we take the derivative, we have 1 over 1 plus x squared is the rule, right? But right now we have 2x inside. So we're going to take 1 over 1 plus 2x squared times chain rule 2.
Put it all the way outside instead of using the denominator.
What?
You put it all the way outside instead of using the denominator.
Yeah, that's how we always do the chain rule. The chain rule is always multiplied to the entire thing.
So we plug that angle in for that x squared.
Mm-hmm. So,
Find the derivative.
right, whatever's inside goes in that, wherever that x. Okay, so back here, our angle was x, so we had x squared plus 1. I'm sorry, I wrote it kind of backwards, didn't I? Yeah, it's okay. Right? Okay, so here our angle's x, and so we have x squared plus 1. Here our angle's 2x, so we have 2x squared plus 1. And then, of course, times the chain rule, so our derivative is 2 over 1 plus 4x squared. Does that make sense?
So the exponent 2 is not part of the derivative. Just take the derivative of 2x and 2x squared.
Right. Right. Maybe let's do another one similar to that. let's find the derivative of, I don't know, arc cosine of 3x. Let's try that. What's our rule for arc cosine? -1 over the square root of 1 minus x squared. So we would have 1 minus 3x, the quantity squared, times chain rule 3. So our derivative would be -3 over the square root of 1 minus 9x squared. Just following a rule, right? Okay, let's step it up a notch. Okay, so arc sine derivative is similar to what we just did, right? It's just positive instead. So 1 over the square root of 1 minus x squared, but instead of x, we have radical x, which we will rewrite in a little bit. But now, we can't forget about the chain rule. How do we do the chain rule? The derivative of the square root of x, which is just x to the 1/2, would be power rule, 1/2 x to the -1/2. So what we have is 1 over the square root of 1 minus x times, this just means 1 over 2 radical x. Do you agree? So we can make this look prettier if we want to. If you left it like this on a test, I would be fine. Okay. But if you wanted to make it look prettier, we could write it as we keep the 2 on the outside, but we can multiply radicals together, and we could write it like this. Okay. I would be fine with you leaving it like this, however. Okay, for right now. Keep in mind when you're checking your answers, okay, they're going to always be simplified in the back of the book. Okay, let's try another one. Let's get some arcsecant going here. Okay, so dy dx. 1 over, okay, so what's our rule for arcsecant? 1 over what? Absolute value of whatever times the square root of whatever squared minus 1, right? So I just kind of put the foundation here, and we can just fill in our blanks. So our angle is 7x squared plus 1. Okay, so there's our arcsecant derivative, and then what do we need to worry about? Chain rule. So we need to multiply by 14x. I would leave this one just as 14x over the absolute value of 7x squared plus 1. Do not multiply 7x squared plus 1 squared out, please. That's not necessary. Okay? Now, since 7x squared plus 1 is always positive, the absolute value isn't necessary, but it is not a bad thing if you have it there. Last example of Unit 2. Are you ready? It's not scary. Oh, Jimmy said product rule. Do you agree? We have x squared times arc cosine. Okay. So when we do the product rule, we take derivative of the first, 2x, times the second, plus the first times what is the derivative of the second? So we have 2x arc cosine x minus x squared over radical 1 minus x squared. For your homework, reference the rules, but what are the three I want you to focus on remembering?
Tangent, cosine, and sine.
Okay, tangent and sine, and along with sine comes cosine. Okay, those are the three that you will see on your test. Okay. So here's your homework. You have time to get started. If you have questions still from inverse derivatives, you can work on those right now and ask me some questions. Okay, I know it's been a weird week with people here and not here and nobody here Wednesday and whatever else. So please use this time wisely.